So this problem has kind of a long problem statement, but let's take it one sentence at a time. It says the load that can be supported by a rectangular beam varies jointly as the width of the beam and the square of its height, and inversely as the length of the beam. So let's use this first sentence to write an equation. It says, we'll start out with the load. So the load, let's write that as a capital L, can be supported by a rectangular beam varies jointly as the width of the beam. So when it varies jointly, that would make the width would go in the numerator, and the square of its height, so the height squared also goes in the numerator. And inversely, so this part's going to go in the denominator as the length of the beam, so I'll make that a cursive L to designate the length of the beam. Also, whenever you're writing variation equations, you need to include the constant of variation, so we'll put a K on the top as well. Okay, so here's our equation. The next sentence says a beam 14 feet long with a width of 4 inches and a height of 6 inches can support a maximum load of 900 pounds. So this next sentence is going to help us find our K value. So if we plug in 14 for the length, let's actually start with the load. So it says the load is 900 pounds. So we'll plug in 900 for the load is equal to, we'll leave K as K. It says the width is 4 inches. So we'll put the width is 4 inches. And then the height is 6 inches. So we'll plug in H is 6 and make sure to square it. Divided by the length is 14 feet. Okay, so wait a second. When I look at the answer, it says that we want the answer to be in feet. So we need to be consistent with plugging in all of our units. So let's go back. We can plug in our 14 as the feet, but we need to convert 4 inches into a number of feet. So what we can do is, since we know that 1 foot is 12 inches, we can take the 4 inches and do a conversion strategy of putting that, since there are 12 inches in 1 foot, I'll put the unit of inches in the denominator so it can cancel out here, and the unit of feet in the numerator, because that's what I want to convert to. And there's 12 inches in 1 foot. So if I multiply that across, I get 4 times 1 is 4, divided by 12 is 1/3. So that's 1/3 of a foot. So let me replace my my width with 1/3. And it says to not round until the very end, so I want to leave that as a fraction and not round it. And then if the height is 6 inches, 6 inches would be half of 12, so that would be half a foot. We could go through the conversion on that one as well, but it's not too bad when it's just a half. Or we could even make that 0.5 if we want, but I'll leave it as a fraction since the other one was a fraction. Okay, so now all of my units are in feet. So I'm all consistent with my units of feet so that I can get my answer in a unit of feet. Okay, so now to solve for my value of K, I'm going to multiply both sides by 14. So 900 times 14 is 12,600. Is equal to K times 1/3, so 1/2 squared would be 1/4, and then 1/4 times 1/3 would be 1/12. So let's multiply both sides by 12 as well to cancel that out, and gives us K is equal to 151,200. Okay, so that gives us our value of K. Now that we've found our value of K, we can rewrite our equation replacing K with this number. So we can make this L is equal to 151,200 times W times H squared all over L. Now the question is asking if a similar board has a width of 8 inches and a height of 5 inches, how long must it be to support 1,400 pounds? All right, so we are looking for the length because it says how long must it be. So what we're looking for is the length. We can plug in the 1,400 into our load. So that would be 1,400 is equal to 151,200 times, it says the width is 8 inches, so we need to convert that into feet. If we have 8 inches, that would be double this, double the 4 inches, so that should make 2/3 of a foot is the width. And then a height is 5 inches, so that would be 5 inches times 1 foot over 12 inches would be 5 over 12 feet. So let's plug in 5 over 12 for the height and make sure to square that. And then the length is what we're looking for. So to solve this, in order to solve for a variable in the denominator, we first need to multiply both sides by that variable to get it into the numerator. So that makes 1,400 times the length is equal to, now let's multiply this out. 5 over 12 squared would be 25 over 144. Then we can multiply the 25 by 2 to make that 50. Here, let's work this out. So it would be 50 would be the numerator divided by 3 times 12. But that would be a fraction. So let's hold on just a second. This would be, let me just get it into a fractional form, would be 151,200 times 50 gives us a really big number, 7,560,000 for the numerator over 3 times 144 is 432. So then to finish solving for L, we need to divide both sides by 1,400. Which dividing by a fraction means the same thing as flipping it and multiplying it. So we'll be multiplying, this will become 1 over 1,400. So we'll multiply the 432 by 1,400 to give us 7,560,000 over 604,800. So this is the fractional answer, but we need to round it to 2 decimal places. So let's divide it out. And I get that to be 12.5. Not too bad. So this would be 12.5 feet would be our final answer. So I hope this video was helpful for you. If it was, please subscribe to my channel and hit the bell for to know when I make new videos. And comment if you have any questions.